Okay, here we go. This is chapter 7.2, right triangle trigonometry. Not a whole lot in terms of math on this point, or actually doing math, but there is some things that you need to be exposed to. So, example 1, in any right triangle, there is one right angle and two acute angles. So keep in mind the reason it's called a right triangle is because it has that right angle in it. That right angle is a 90-degree angle. You may remember from geometry that all three angles in a triangle always add to 180. So that means if one of those angles is a right angle and taking up 90 degrees of that 180, the other two have to add to 90 as well, okay? So the longest side of the right triangle is called a hypotenuse. The longest side will always be across from the largest angle, so the hypotenuse is always across from our right angle. The other two sides opposite the acute angles are called legs. Okay, so notationally here, just in case you forgot, this little square here in the corner, that's what shows us that this is our right angle. So typically, C is the right angle. And I'm just going to stick that over here. And since the hypotenuse is across from that, that makes our little c the hypotenuse. Sometimes we have triangles that are labeled DEF, MNO, whatever. If it's got an ABC and the triangle itself is not labeled, pretty safe guess to think that that C is the right angle and the little c is the hypotenuse. Okay, so in a triangle we've got three sides, which means there are a limited number of ways we can use two of them to make a ratio. Keep in mind a ratio basically is a fraction. Okay, we're comparing two parts. So with three sides, there are 6 ways to use those three sides to make a ratio with two pieces. 3 of them are novel. The other 3 are just the reciprocals. We flip numerator and denominator. So the 3 most common trig ratios are the sine, cosine, and tangent. Sine we abbreviate SIN, cosine we abbreviate COS, tangent we abbreviate TAN. You guys will notice down here that sine by itself doesn't mean anything. It's got to be the sine of something. We need to know which angle we're talking about. So it's like a square root. Square root symbol itself doesn't mean anything unless we have a number underneath or an argument. Same thing with our trig ratios. There has to be an argument, okay? So take a look at that sine ratio. That says opposite over hypotenuse. And what we're referring to here are the lengths of those sides. So when we're talking about a given angle, the side opposite it is the side that does not make up one of the sides of the angle. So it is the side that physically does not touch the angle at all. The hypotenuse will always be across from the right angle. And then we have an adjacent side, which is the side next to the angle that is not the hypotenuse. Okay? So keep in mind we're talking specifically about angle A here. If we were talking about angle B, hypotenuse would stay the same. The opposite and the adjacent sides would swap, be different. Okay? So the sine is the length of the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the other 3 trig ratios, we don't use them as often, but we will see them. Cosecant is the hypotenuse over the opposite. The secant of A would be the hypotenuse over the adjacent, and the cotangent of A is adjacent over opposite. Okay? The easiest way to remember, and you will hear people talk about this, SOHCAHTOA. That is the mnemonic that we use to help remember the relationship for a given trig function, trig ratio. So the sign here are S, OH, opposite over hypotenuse, and all that's laid out in this table at the bottom. Cosine, AH, cosine is the adjacent over the hypotenuse. And then the TOA, tangent, is opposite over adjacent. That's it for page 1. I will see you on page 2.